Welcome to AskPrep, your trusted companion for NEET and JEE preparation. Today we will study about a very important topic of physics, which is Coulomb's law versus gravitational law, a comparison. Imagine two fundamental forces of nature, electric force and gravitational force. While both govern interactions in our universe, they exhibit striking differences in behavior and properties. Today, we will explore and compare Coulomb's law and gravitational law, understanding their similarities and distinctions. Coulomb's law describes the force between two charged particles. This force can be attractive or repulsive, depending on the nature of the charges involved. If the charges are of opposite signs, the force is attractive, pulling them toward each other. If they are of the same sign, the force is repulsive, pushing them apart. The strength of this force depends on the magnitude of the charges and the distance between them. On the other hand, gravitational law describes the force of attraction between two masses. Unlike the electrostatic force, gravity is always attractive, never repulsive. Every object with mass attracts every other mass, and the strength of this attraction is directly proportional to their masses and inversely proportional to the square of the distance between them. One of the key differences between these two forces is their relative strength. The electrostatic force is significantly stronger than the gravitational force. This difference is evident when comparing the forces between two elementary particles, such as protons or electrons. The electric force between them is immensely greater than the gravitational attraction, making electromagnetic interactions dominant in atomic and molecular structures. Another critical distinction lies in their dependency on the medium. The electrostatic force can be influenced by the surrounding material, as different substances affect the force between charges. In contrast, gravity is unaffected by any medium, it acts universally, regardless of the presence of matter in between. The range of these forces also differs. While both follow an inverse square law, meaning their strength decreases with distance, gravity has an infinite range and remains significant even over astronomical distances. The electrostatic force, though also theoretically infinite in range, is often neutralized in large-scale systems due to the presence of equal positive and negative charges. In real-world applications, both forces play crucial roles. Coulomb's law governs the behavior of electric charges, influencing fields such as electronics, chemistry, and material science. It explains how charged particles interact, how atoms form molecules, and how electrical devices function. Meanwhile, gravitational law is essential in understanding planetary motion, satellite dynamics, and the structure of the universe. It dictates how celestial bodies interact, leading to the formation of galaxies, stars, and planetary orbits. Another major difference lies in the medium of interaction. Gravitational force does not require any medium and acts in vacuum as well as in matter. Electrostatic forces, however, can be influenced by the surrounding medium. The presence of other charges, conductors, or insulating materials can alter the strength and nature of the electrostatic force between charges. This is why materials such as dielectrics are used in capacitors to store electrical energy efficiently by modifying the electrostatic field between charged plates. The impact of these forces on everyday life is significant. Gravitational force is responsible for our weight, the motion of celestial bodies, and the structure of the universe. It is a force that operates at all scales, from the smallest dust particle to massive galaxies. Meanwhile, electrostatic forces are responsible for numerous technological applications, including capacitors, electric circuits, and even biological processes such as nerve signal transmission in the human body. The attraction between hair and a charged comb or the shock felt when touching a metal surface after walking on a carpet are examples of electrostatic interactions in daily life. Understanding the nature of these forces allows us to appreciate their significance in different fields of physics. Electrostatic force governs atomic and molecular interactions, making it essential for chemistry and material science, while gravitational force governs large-scale interactions in the universe, making it fundamental in astrophysics and planetary motion. Scientists have studied these forces extensively, leading to advancements in various technologies, including space exploration, electronic devices, and medical applications. The range of these forces is also a crucial factor to consider. Both forces act over an infinite distance, meaning they do not have a specific cutoff point beyond which they completely disappear. However, their effects become weaker as the distance between the objects increases. The influence of gravity is particularly significant on a cosmic scale, binding celestial bodies together in galaxies and planetary systems. Coulomb's force, on the other hand, is more noticeable in everyday interactions, such as in static electricity or the functioning of electronic devices. One of the most fascinating aspects of these forces is how they shape our universe. Gravity is responsible for the formation of stars, planets, and galaxies. It dictates the orbits of celestial bodies and determines the structure of the universe on a large scale. Without gravity, the universe as we know it would not exist. On the contrary, Coulomb's force is responsible for the structure of matter at the microscopic level. It binds electrons to nuclei, holds atoms together to form molecules, and plays a crucial role in chemical reactions and biological processes. Despite their differences, Coulomb's law and gravitational law share a fundamental mathematical structure, highlighting a deep symmetry in nature. Both obey an inverse square relationship, meaning that as the distance between two objects increases, the force between them decreases proportionally to the square of that distance. This similarity suggests an underlying unity in physical laws, even as they govern distinct aspects of reality. In conclusion, while Coulomb's law and gravitational law describe forces that shape our universe, they operate in fundamentally different ways. The electrostatic force is much stronger, acts between charges, and can be both attractive and repulsive. Gravity, in contrast, acts between masses, is always attractive, and dominates large-scale cosmic interactions. Understanding these forces helps us grasp the fundamental principles of physics, from the smallest atomic structures to the grandest cosmic phenomena. Thank you. This is AskPrep, your guide to mastering NEET preparation. Let's decode complex topics and simplify your journey to success.